one more day in lesson 4.2, and this is officially solving right triangles. Now, before we get to that, I want to review the chart, okay? This chart we will quiz on. I don't really know because the schedule's all messed up, but it could be the very beginning of next week is what I'm thinking, okay? All depends on how this week flows, and yeah. So, anyways, this chart, we talked about degrees and radians. This is just good to memorize, so you don't have to convert them every time. You can convert them, right? Multiplying by, okay? How about pi over 180, right? Now, if we just memorize them, 30 degrees is pi over 6 radians. 45 degrees is pi over 4, and 60 degrees is pi over 3. So know those, right? Okay, those are your main 3 first quadrant angles. Okay, we filled in the triangles before we got started here, right? 45, 45, 90, the legs are equal. Hypotenuse is square root of 2 times the leg. 30, 60, 90. Short leg, opposite 30 is our 1. The hypotenuse is 2 times that, and the long leg, opposite 60, is square root of 3 times the short leg. Okay, what's the sine of 30 degrees? 1/2, because it's opposite over hypotenuse. Let's go ahead and keep going 30 degrees. What's the cosine of 30 degrees? Square root of 3 over 2, because it's adjacent over hypotenuse. And tangent. Okay.
Or 1 over square root.
Square root of 3 over 3 is our rationalized version. That's the one that honestly you definitely need to be familiar with. Okay. However, where did that come from? 1 over square root of 3. And that is opposite over adjacent. I'm content with either or, but I cannot stress enough, it will help your pre-calculus skills so much if you're familiar with both. Don't just think, I'm going to forget that one, I just want to know the one. Be familiar with them both. Okay? Okay, 45 degrees. If we flip to the other triangle for a moment, what sine? Okay, officially when we do opposite over hypotenuse, it's 1 over square root of 2. The rationalized version of that is square root of 2 over 2. What do you know about cosine of 45?
1 over square root of 2.
Okay, it's also 1 over square root of 2, 1 over square root of 2, and square root of 2 over 2. What about tangent?
1.
It is just 1. Opposite over adjacent, 1 over 1. And then 60 degrees. What is the sine of 60?
Square root of 2.
Opposite over hypotenuse, opposite over hypotenuse, square root of 3 over 2. Cosine of 60?
1 over 2.
Adjacent over hypotenuse, 1/2. And tangent of 60? Square root of 3 over 1, which we traditionally write as square root of 3. Okay, guys, memorize the triangles, and the chart's a piece of cake to fill in as long as you know SOHCAHTOA, which I'm saying that Mrs. Rogers covered SOHCAHTOA quite well with you, and you know that. Okay? Now, with that in mind, know these. The more we do this, though, the more you'll be able to just fill in the chart without having to even look at the triangles. Okay? Okay. So let's just kind of review side note for a moment. Obviously, you have it on your previous page in your notes too, so you can use that to check. Now, what we're looking at is finding the missing sides and angles of triangles today. So you'll be given, what, minimum 2 pieces of information, I think? And our job is to find whatever missing sides and angles they ask. Whether they say find all the missing sides and angles, or whether they just specifically name a few. In our examples here, we've named a few. So in example A, we know it's a right triangle. All of these are going to be right triangles right now, okay? That's all we know. So we're working with right triangles. And in that, so I guess 3 pieces of information they're giving us, because it has a 90-degree angle, has a 37-degree angle, and there is one side length given as 8. And they are asking us to find the other sides. Well, actually, okay, no, it is all missing sides and angles. The angles just aren't labeled. Okay? So, what's your thought, Kylie?
Don't all triangles equal 180?
All triangles
Oh my god.
add up to be 180 degrees. So how does that help me, Kylie?
Well, if you do 37 plus 90,
Uh-huh.
subtract 180, then you'll have your missing angle.
Okay.
Subtract 180.
Oh, I'm so sorry, Sophia. I missed.
So, 37 and 90, add those two together, subtract from 180. Whatever order we want to do this, and this will find our missing angle, because all three angles in a triangle always add to be 180. You will need calculators today, by the way, folks.
Oh.
So if we do 180 and we subtract 90 and 37, what do we end up with?
53.
Okay. And you could also have done the 90 plus 37 is 127. 180 minus 127 is 53. There's another way we technically could have done it.
I just take
I just added up to 90.
You just what?
I just take out the 90 altogether, so it's just 90.
So if we take out the 90 altogether in Sophie's words, meaning the other two angles will always add to be 90. And so another option is to do just 90 minus 37, yes?
Yeah.
And that is true as well. Okay? All I care is that you can find this 53 degrees. You probably learned that back in middle school. I don't know. Somewhere along the line you learned that. Somewhere probably before geometry. If not, I can guarantee you it happened in geometry as
I'm
well.
gonna subtract.
Okay, next. We need to find A, and we need to find B. I'm ready for suggestions.
Use the sine of 37.
Okay, how's the sine of 37 going to help me here?
To find A.
How are we going to do that?
Yeah, how are you, Sid?
8 times the sine of 37 equals A.
This was 37.
Okay, so she's on the right track here. Have you guys done this in physics maybe?
Yes.
Okay.
No.
I don't know what she's talking about.
Okay, so here's the deal, guys. We know an angle of 37 degrees, yes? We know, what is this, 8? The hypotenuse. And if we're going to start by finding A, doesn't matter which side we start with, what connects the 37 degree angle, the A, and the 8? And that is what trig function? That is sine. Because A is opposite 37 degrees, and 8 is the hypotenuse. And so the sine of this angle is going to be equal to opposite over hypotenuse. So I can set up a little equation. And I'm going to set up and say the sine of 37 degrees is equal to A over 8. That's the part I was looking to get out of Sophie, but she just knew what she was doing and was doing it in her head. So you're fine. You're fine. You knew what you were doing. You're on the right track. I just have to get it on paper for everybody else. So that's my setup. Are we okay with where this equation came from? Okay.
Yeah.
It's 37 degrees. Don't worry about the calculator part. I'll get to that, okay? I'm concerned, do we understand how to get this?
Yes.
The fact that 37, if I'm trying to find A, that's the opposite side. So I need something that uses 37 degrees and the opposite side. I know the hypotenuse. So that's my sine. Now, think like an equation. If we're trying to get A by itself, if it's A divided by 8, what do? You're going to multiply by 8. And so that means I'm going to multiply the sine of 37 degrees by 8. So I'm going to write this as A is going to be equal to 8 times the sine of 37 degrees. Do you know the sine of 37 degrees?
No.
No. Is that one that was on our chart?
Yes.
No.
Yeah.
We've got 30, 45, and 60 are our three magic angles. We're not going to see those today. So this means we have to go to the calculator.
Oh.
Okay? So these are calculator required problems.
Great.
And it is as easy as typing in 8 sine 37 degrees. Now, here's the deal. We're not multiplying 37 by 8. We're multiplying
Sine.
the sine of 37 by 8. So honestly, if I'm doing this, I'm going to type 8 sine 37, and hit it. And you should get a matching answer with me. If I want to be fancy, I could say 8 times sine of 37.
How many
Okay.
decimal places do you take it to?
Are you in
I have
radian
2
or degree
decimal
mode?
places. Yes, Noah?
You in radian or degree mode?
Would I be in radian or degree mode?
Degree.
And why would I be in degree mode?
Because they give you a degree.
Because it gave me 37
I'm
degrees.
just making sure you were in. I knew the answer.
Okay?
Oh my God.
Well, what am I waiting for? I'm waiting for someone to complain I didn't get that answer.
Yeah, I got a negative.
So, if you were someone sitting out there saying, why is no one complaining their answer doesn't match? What did I do wrong? Check your mode. If you're still in radians, you need to flip-flop to degree mode. Yes?
Yeah.
Okay. Now, let me show you what you cannot do. You cannot do sine 37 and not end your parentheses and say times 8 like that.
That's crazy.
Okay? You could, if you wanted to, whoops, say sine 37. You could end your parentheses and then multiply by 8. And that would be okay.
That's fine.
Okay? But you have to make sure you end those parentheses if that's the case. Your calculator doesn't require you to end those parentheses. So as I said, I have 2 decimal places, which is 4.81. Okay? Not done. Because, let's see. Angles, they gave me 90, 37. I found 53. Angles, done. Easy peasy. They gave me 8. I found A. I don't know B.
Not green theorem.
A squared plus B squared equals 6. No,
I would strongly suggest we not rely on Pythagorean theorem today. Now, here, okay, listen. If you listen to my wording, I would strongly suggest we not rely on Pythagorean theorem today because that's not what I'm teaching. Am I saying that Pythagorean theorem would not yield the same answer? I'm not saying that. Pythagorean theorem would yield the same answer. However, I need you guys to practice the task at hand, which is how do we use trig functions to find these. So, and what I would even think of, if I didn't know A, how do I find B? And if you don't know A, you can't use Pythagorean theorem. So what's a connection I could use to find B?
The cosine.
Could we use the cosine of 37 degrees? Because then B is the adjacent side, and the hypotenuse, again, is 8. So you could say the cosine of 37 degrees is equal to B over 8. How do we solve for B?
Cosine of 37.
Yeah, you're going to multiply by 8. So it's going to be 8 times the cosine of 37 degrees. As long as you know what you're doing, I don't care how you enter your calculator. On paper, you're always going to see me multiply that 8 out front, so it doesn't get confused with the 37. Did we get an answer?
Yep.
6.39 is your rounded answer? Okay. Now, and here's the deal. If you use Pythagorean theorem, your answer is very possibly going to be slightly off if you use a rounded answer of 4.81. Okay. If you use the full answer, it's going to be more accurate. Did anyone find B a different way?
Yes.
How'd you find B?
The sine of it.
The sine of 53. What does that work?
Because B is also opposite.
Now, 53, is that a precise answer? That's an exact answer, isn't it? It's not rounded.
Yeah.
So I'm okay with using 53 then. So 53, opposite is B, hypotenuse is 8. Could we use the sine of 53 equals B over 8? Got the exact same answer, didn't it? Okay. Right or wrong? There is no, there is none here. Okay. They're both good. Okay, so do understand that there's a lot of flexibility here. Pythagorean theorem. I don't know if anyone tried it just out, just for kicks, but you would have gotten the same answer. So I don't even think Noah has a calculator today.
I changed its batteries, and I don't have my backpack. I have a new thing. I have this. It's all to myself. It's all in here.
I don't, not that this calculator business is as confusing as the other day. I think when, it's basic, you hit the button, but still, to practice. I have no idea that's in whatever mode you left it in last, Noah, so FYI. Okay. Some of you guys are working ahead of me. I'll catch up here in a moment. Let's try B.
33. Yes,
What is 33?
57.
The
minus
angle that
50.
we don't know is 33.
It is
that's the
33.
same thing.
I actually did that when we were on the.
Okay. And how do I know that missing angle is 33? Remind me.
57 plus 13.
That's right.
Okay. So you have a way, right? 57 plus 33, subtract from 180, or 180 minus 57 minus 33, or 90 minus 57. One combo or another. I'm just going to write 180 minus 57 minus 90 is 33. I don't really care how you find it. Okay, now we have to find x and y. Thoughts?
Well,
Sine of 57. No. Yeah. Equals 13 over x.
Okay, so one option. Sine of 57 degrees is 13 over x. Is that an option?
that's what I got.
Okay, that works. So sine of 57 degrees is equal to the opposite of 13 over the hypotenuse of x. Okay, think equation solving. How do I solve for x? My brain's going to say, since it's 13 divided by x, I'm going to multiply the x over to the other side. Okay, so me personally, I would multiply the x over here and say x times the sine of 57 degrees is equal to 13. But then how do I solve for x? If it's x times sine, then we're going to divide. And keep in mind, as I move that sine of 57 degrees, it is one amount. Sine and 57 are not separate things. You keep them together. So now we're doing 13 divided by sine of 57 degrees. And this is an option. If you're going to tell me you found it a different way, I'm not going to argue. Okay, as long as you get
0.06.
say what?
15.50.
I'm looking for 15.5.
That's what I got. Yeah.
So what did you do?
I put sign on top.
Okay, there's a problem.
That would be a problem.
Okay. So you found the reciprocal. Didn't need the reciprocal, but thanks for finding it. Okay. So that was an option to find x. What is an option to find y?
33. With 13. Y over 13. 13 over y.
Opposite over adjacent.
Y over.
Tangent of 33.
Sure, let's go with that. Mario seems confident.
Okay. So here's my recommendation. Is that we do a tangent operation of some sort.
Yeah.
Okay. My recommendation is a tangent. And officially, we could do tangent of 57 or tangent of 33. Now, I heard some cosines. I've heard some things that we're going to end up putting y over x. And I'm not 100% against that, but here's the deal. If you use x and you use the rounded version, you're going to get a slightly different answer. So my suggestion is if you try and use x, use that full calculator answer if you try and use x. And you should succeed okay. My recommendation is, in all honesty, use the exact 13 and the y. And so if we use 13 and y, we're going to use tangent of something, depending on which way we want to do this. So, tangent of which angle should I use?
57.
Okay. If we use tangent of 57, then what is my fraction equal to?
13 over y.
13 over y. what's the other option here? Tangent of 33 is equal to y over 13. And here's the deal. I don't care if you use 33 because that is an exact non-rounded answer, yes?
Mhm.
As long as, now the only thing that could get you in trouble is if you accidentally subtracted wrong and you got your 33 wrong. That's the only thing that's going to get you in trouble for using 33. Okay? So, if I multiply y to the other side, I have y times the tangent of 57 degrees is equal to 13. If I divide, I'm going to have 13 divided by tangent of 57 degrees. And what do we get?
8.44.
Okay. I'm told 8.44. Everyone agree?
Yes. Even.
Okay. One last one. Although you guys have probably got this under control by now, I'm guessing. But okay. C, what do you know?
69 degrees. That's what I got.
Okay. Our missing angle here, 180 minus the 90 minus the 21 is going to be 69 degrees. And do we want to find N or do we want to find M?
Let's go in because it comes first.
Okay, so if we're in an alphabetical mood,
That's
how do we find M?
Tangent. 21.
Okay, tangent of 21. I could do that. And here's the deal. Well, yeah, if we're trying to find M, and M is either opposite or adjacent, and the 14.2 we know is opposite or adjacent, you're using a tangent function here, aren't you?
Yeah.
Okay, so tangent of 21 degrees is equal to M over 14.2. Or if you use tangent of 69, you have 14.2 over M, right? The advantage of putting M on top, though, is it's just a multiplication step, isn't it?
Exactly.
If it's M divided by 14.2, we're going to multiply. So we're doing 14.2 times the tangent of 21 degrees. And your fingers do the talking here, right? On the calculator buttons. And what do we get for M?
5.45.
Okay, that's what I have written down. 5.45. And N. What would you like to do to find N?
I got to think. That's where I'm at.
for what?
We'd find N. And here's my thought. So you're trying to use cosecant because it's a reciprocal of sine. Wait a minute. Oh, which angle are you? I guess it depends.
I was just throwing that around.
Okay. And here's the deal. My recommendation is to avoid the cotangent, cosecant, and secant on these, just because you then have to do reciprocal buttons on your calculator. It just gets more confusing. Okay? You do what? Cosine of 21? I could do cosine of 21. If I do cosine of 21, cosine is adjacent over hypotenuse. So 4.2 over n. So if I multiply n across, n times cosine of 21 is equal to 14.2. If I divide, n is going to be 14.2 divided by cosine of 21 degrees. And n is 15.21.
Oh my gosh. We were in sync right.
Okay. If you've done some other things, you're getting equivalent answers. That's good. Okay. I don't think I've written it down today. Probably should have written it up top.
I did.
SOHCAHTOA has been a theme again, hasn't it?
So,
Okay. You gotta know it. Okay. One more example. And that is our word problem of the day. These type problems, the skills we were just learning, lend themselves to word problems like crazy. Okay? These are big things. There's a lot of word problem applications we can do here. Now, my number one suggestion is going to be draw a picture. And when you draw pictures with these, you're going to magically just happen to find a right triangle within your picture somewhere. Okay? It's magic. They always happen, okay? So, from a point 340 feet away from the base of the Peachtree Center Plaza in Atlanta, Georgia, the angle of elevation to the top of the building is 65 degrees. Find the height, h, of the building. Okay. So, I have a Peachtree Center Plaza. Which Peachtree Center Plaza is?
is that actually a real place?
I'm assuming so.
No, why don't we just
It's a building. Okay, there's my building.
Siri, what's
And here's the deal. Do you even need this much? No, just draw a vertical line. There's your building, okay? From a point 340 feet away from the base. So that means over here somewhere, there's a person. I'm getting fancy with this picture. I don't normally get this fancy, okay? There's a person. Because it says the angle of elevation. What's the angle of elevation? That's when you're standing at ground level and looking up. So the angle of elevation to the top of the building. So where this person is looking for, we're trying to find that angle right there. Or no, we're not trying to find it, excuse me. That angle is
65.
65 degrees. And what else do we know? That person is standing 340 feet away from the base of the building. And what are they asking us to find? The height of the building. Well, what should we be able to assume about the building and the ground?
They're flat.
We should assume the building and the ground form a right angle.
Sure, so
That is a logical assumption, okay? So with this information, I have magically created a right triangle. I know a 65-degree angle, I know a 340 length side, and I'm trying to find another side. What are we doing here? Tangent of 65 degrees, I like it, is equal to what? Okay, it's equal to opposite over adjacent, which is h over 340.
So tan 65 times 0. Or
So,
340 times.
yep.
You know.
In order to find h, we're going to multiply 340 times the tangent of 65 degrees. And we're going to get a calculator answer of 729.13, and that would be in terms of feet. Now, you'll see tangent in a lot of word problems, to be honest. However, that's not always the case, okay? Draw a picture, look for those connections, is what I will say there, okay? Questions?
This is like my favorite lesson because I already know what's going on.
Well, it's really a relatively easy lesson. Work to understand your setups, just like you know that chart. We're really hitting SOHCAHTOA hard here. We have to know the pieces. Make sure you know what you're doing. You've got about 5 minutes. You can at least get a paper out, labeled, numbered, you know, the basics.
Oh, I already got